This lesson is going to take just a brief look at the idea of predicting outcomes, using your probability to plan out how many you should have. It's not a difficult concept. A lot of it's intuitive, which means you can look at the situation and yeah, it makes sense. So let's take a look at a coin. We know the chance of a head is 1/2. We know the chance of a tail is 1/2. So how do I project this onto, let's say I want to flip a coin 100 times. Okay, so if I would flip a coin 100 times, 100 flips. How many heads should I get? Again, this is intuitive. It should make sense. You should be able to say, oh, well, it's half and half. I should get 50. Well, if you get a probability that's harder to look at than 1/2, what you can simply do is this. Take your probability and multiply it by the number of outcomes that you have, or number of trials you're going to do. And again, this is multiply. Very simply done in a lot of probability, especially the other lesson, compound, we use multiply. So I'm going to take my probability of 1/2. I'm going to multiply it by the number of trials I'm actually doing. Multiply by 100, and we know the answer is 50. Now what you have to remember is this is what should happen. Doesn't mean it's guaranteed, but at least should put you in the ballpark. And when we get into experimental probability, we'll start understanding a little bit more of sometimes it works, sometimes it doesn't. Let's go down to a die. So probability of each of the numbers is 1 out of 6. Let's do probability of 3. We know that's 1 out of 6. And let's say this time I'm going to do 36 die rolls. Now I'm picking nice easy numbers because when I multiply it reduces. So again, I would take my probability 1/6 times number of trials that I'm doing, the actual amount of times, and I should get 6. I should get 6 3s. So this is predicting outcomes. Very simple. Take the probability times the number of events you have, and it should give you the ballpark, the estimate, how many outcomes you should have. Okay, so let's apply this idea. I'm going to take a look at the spinner we used before. 1 red, orange, green, yellow, and I have 2 purple. Remember, if I would split this, I would have 2 purple. So my purple becomes 2 out of 6 total pieces. So I wrote my probability here, and I'm going to multiply it by 6. I'm going to do 6 spins. And I'm going to record results. And I'll move this over here. So what this allows me to do is change the number of spins. So I want 6. Now if I would use my calculations, 2 6 times 6, I should get 2. Now that should make sense that, okay, if I would spin it 6, I should get 1 of each of these and 2 purple. So now the question is, does that happen? If I look at my results off to the side, it did happen. Alright, I did get 2 out of 6. Will this happen every time though? A lot of you are saying, no, it's not going to happen every time. And you're right, it doesn't guarantee it's going to happen, but it should. Spin again, and I get, again, 2 purple. What if I do out of 12? This becomes 2 and I get 4. So I should get 4 purple. So let's change this to a 12. Does my prediction work? I should get 4. Well, it didn't work. I got 3. But again, it's close. It should be close. Let's try it again. I got 3. Again, not quite there, but close. This time I got 5. Well, that makes sense. I was getting 1 under my prediction. Now I'm getting 1 over. If the world's going to balance out, I should get another 5. Let's spin again. This time I got 7, so it was more over. This time I got exactly 4. I got 3. So again, notice how the prediction gives me the ballpark, but it's not always guaranteed it's going to work out that way. Let's try a higher number, see what happens. Okay, same idea. This time we're going to do 600 spins. Same probability, 2 out of 6. multiplied by the number of trials, 600, and I should get 200. So let's change this to 600. Now it's hard to see, but this number up here is 201. That's pretty close to exactly getting what I want. So let's try it again, see if I get 200. Remember, this is a prediction. It's not always going to be exactly right, but it should get me in the ballpark. 212. Again, when you're dealing with in the hundreds, 12 off isn't that much. Let's clear it again, 2 more. $225. Again, so it's higher, but 25 off is not that different when you're talking in the hundreds. Try it one more time. Should be close to 200. 202. So again, what it shows is my prediction should get me close no matter what if I use my probability times the number of trials.